Hello everyone and welcome to our educational session. My name is Paul Arsuf and I'm the founder of the Decentralized Web project. I'm going to talk about this and several other projects that we're working on in the end of this presentation. But today's topic is part 2 of the presentation called Vibe Coding when the AI is railroading developers. In part 1 we were talking about specifically about AI models, and some of these models are used for vibe coding, and some of them just normal chat, image generation, and etc. The perverse incentives of AI code generation point to a more fundamental issue that extends beyond coding assistance. When we are looking at benchmark tests, like for example Giscard's AI FAIR, this reveals a troubling pattern that mirrors our coding dilemma. Demanding shorter responses jeopardizes the accuracy of the answers. According to these findings, instructions emphasizing consciousness, like answer these questions briefly, significantly degraded factual reliability across most models tested, in some cases causing a 20% drop in hallucination resistance. When forced to be concise, models face an impossible choice between fabricating short but inaccurate answers or appearing unhelpful by rejecting the questions entirely. The data shows models consistently prioritize brevity over accuracy given these constraints. There is clearly something going on where the more verbose the LLM is, the better it does. This actually makes sense given the discovery that chain of thought reasoning improves accuracy, but this issue has begun to feel like a real trade-off when it comes to these almost magical systems. We see this exact tension in code generation every day. When we optimize for consciousness and ask for the problems to be solved in fewer steps, we often sacrifice quality. The difference is that in coding, the sacrifice manifests as over-engineered verbosity. The model produces more tokens to cover all possible edge cases rather than thinking deeply about the elegant core solution or root cause problems. In both systems, economic incentives, token optimization, work against quality outcomes, factual accuracy, or elegant code. Just as fair benchmark research suggests that seemingly innocent prompts like be concise can sabotage the model ability to debunk misinformation. Our experience shows that standard prompting approaches can yield bloated, inefficient code. In both domains, the fundamental misalignment between token economics and quality outputs creates a persistent tension that users must accurately measure. But what are some tricks to manage these perverse incentives? While we wait for AI companies to better align their incentives with our need for elegant code, we have developed several strategies to counterfact verbose code generation. The first trick, we call it, is to force planning before implementation. We could harass the LLM to write a detailed plan before generating any code. This forces the model to think through the architecture and approach rather than divide and dive straight into implementation details. Often we find that well-articulated plan leads to more concise code as the model has already resolved the logical structure of the solution before writing a single line. The second trick is explicit permission protocol. We have implemented a strict ask before generating protocol in our workflows. Our persistent, for example, Cloud MD file explicitly instructs Cloud to request permission before writing any code. Infuriatingly, Cloud Code regularly ignores this, likely due to its massive system prompt that talks so much about writing code it overrides our preferences. Enforcing this boundary and repeatedly belaboring it, remember, don't write any code, helps prevent the automatic generation of unwanted verbose solutions. The third trick is Git-based experimentation with rootless pruning. Version control becomes essential when working with AI-generated code. We frequently benchmark code with Git when we arrive at an okay, it works as intended moment. Creating experimental branches is also very helpful. More importantly, we are ready to throw out branches entirely when fixing them would require more work than starting from scratch. This willingness to abandon sunk costs is surprisingly important. It helps us work through problems and figure out the AI's hang-ups while preventing the accumulation of band-aid solutions on top of fundamentally flawed approaches. The fourth trick is use a cheaper model. Sometimes the simplest solution works best. Using a simpler, cheaper model often results in more direct solution. These models tend to generate less verbose code simply because they have limited content and context windows and processing capacity. While they might not handle extreme complex problems as well, for many day-to-day coding tasks, their constraints can actually produce more elegant solutions. Tasks, for example, Claude 3.5 Haiku is currently 26% the price of Claude 3.7, like 80 cents per token versus $3 per millions of tokens. Also, Claude 3.7 seems to over-engineer more frequently than Claude 3.5. So what are the path forward, moving towards better alignment? Um, so what could a better approach look like? LLM coding agents could evaluated and incentivized based on code quality metrics rather than just token counts. The challenge here is that this kind of metric is quite subjective. Companies could offer pricing models that rewards efficiency rather than verbosity. We have currently no idea how this would work. This was Claude's dumb idea. LLM's training should incorporate feedback mechanisms that specifically promote concise, elegant solutions via uh, reinforcement learning human feedback, showing developers multiple versions of the same code and having them pick the optimized one. Perhaps this is already happening. Companies realize that overly verbose code generation is not good for their bottom line. Um, like, for example, Sam Altman admitted that users saying please and thank you to ChatGPT is costing them millions of dollars. This isn't just about getting better AI. It's about making sure that the economic incentives developing and driving AI development aligns with what we actually value as developers: clean, maintainable, elegant code that solves problems at their root. Until then, don't forget, brevity is the soul of wit, and machines have no souls. Um, um, like personally, we can tell that we use code to help write some parts, and these parts are verbose. The perverse incentives aren't embedded in the models themselves, but in the business decisions surrounding them. In other words, we should be blaming AI, we should be blaming the company behind AI and the humans that are optimizing their business revenue models. The machines are just doing what they're told, even when that includes explaining how they're being told to do too much. And with this said, I'm ending this part 2 of this presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project. Decentralized Web project built a decentralized communication and advertising platform. It has its own blockchain instance, and this blockchain instance rewards people who come to our platform to become new users with tokens from this blockchain instance that we're running, and it rewards users for inviting other people to become new users with tokens, and it rewards users with tokens for viewing advertising, which is very, very permissive. The user could request start viewing advertising by a clicking of a button, and then they have to click on button to advance from one ad to the next ad and to the next stat, and it is very permissive. For doing this, I repeat that users are rewarded with tokens. The meaning we put in decentralization and the implementation, our implementation of decentralization is different than the meaning and implementation that blockchain technology does. We view blockchain technology as fundamentally not suitable to drive decentralization, and in our implementation of decentralization, we allow only direct communication from user to user without going through a third party, namely a web server or a central point which collects or stores information, and then it distributes this information back to the users. Once again, we only do direct communication from user to user. With this said, I like to tell you the name and the URL of the project. It is decentralizedweb.org. Decentralized and web, these are two words which are typed all together. Decentralized web. Then there is dot and it ends with org. With this said, I like to go to the next project that we did build and release, and this project built a marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With three-dimensional objects, there has to be a special software which loads, reads the 3D object and displays the 3D object on a computer screen. In general, creators of 3D objects, they're using commercial software, and currently there are two very popular choices of 3D software engines, and the first one is a game engine called Unity. The second choice, very popular, is a game engine called Unreal. But from the very beginning of our 3D NFT projects, we decided to build our 3D software engine, and what it does, it reads the 3D NFT object file, then it opens a window on the computer screen, it displays the 3D NFT object, and then it starts animating the 3D NFT in a way of moving it in a random fashion around the window it did open. But in addition to these initial and basic capabilities, our 3D software engine does has multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices, namely a male voice, female voice, or a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices, a voice can be spoken either in a normal speed or in a fast speed or in a slow speed manner. The second additionally important capability is the capability of voice recognition done in our 3D software engine. If, for example, you have a 3D NFT which is being animated and moving in a random fashion, then you can issue your very first voice command to the 3D NFT to stop moving. and then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands. The next additional important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT what is you can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in a few sentences about Web3 or decentralization, or the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you, the user, could come to our 3D NFT marketplace website, and probably now is the time to tell you the name and the URL of the website of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D, followed by 3 other letters N, F, and T, and it is typed all together 3D NFT. Then there is dot, then there are 2 words typed all together, decentralized and web. Then there is dot, and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you can see a number of links, and one of these links points to links to accessories. When you click on this link, you're going to see that we are offering special glasses, and when you click and order one pair of these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you are going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you are going to see it in real 3 dimensions. With this set, I'm ending talking about our 3D software engine and its capabilities, but I like to tell you something about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and by having our own blockchain instance, we do not charge our users for the deployment of the smart contracts for the non-fungible tokens or the NFTs, and we do not charge our users gas fees for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, also we allow our users to buy and receive proceedings from sell in multiple crypto coins. Currently, the choices include Solana Sol, Polygon Matic, Avalanche AVAX, and Qcoin, which is a big centralized crypto exchange. It has a coin called KCS. By having buying and selling with crypto, and then we have also a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. You can come to our 3D NFT marketplace, you can browse through the collections of the 3D NFTs, and then when you see a 3D NFT that you want to buy, when you click on this, you're going to be presented with a choice of the way of payment, and you have to choose between payment with 4 different crypto coins and a fifth choice of paying with fiat currency. When you select payment with fiat currency and click on the button to advance next, you're going to be presented with a screen where you have to put the number of your debit or credit card, expiration date and CVC, and when you click to complete this transaction, what is going to happen is there is going to be a transaction and a transfer of the payment from your debit or credit card, and it is going to be converted from your national fiat currency, which could be different than US dollar, and the payment is going to be converted to US dollars and deposited in our bank account. Then we're going to follow this with a transaction and a transfer of the initial ownership from our 3D NFT marketplace, and we are going to make a transaction to assign to you the ownership of this 3D NFT. You can play with this 3D NFT for a while, and at some point you could put this 3D NFT for sale. You decide on the price that you want to put for sale, and let's say there's a second user who comes to our 3D NFT marketplace. They browse through the collections of 3D NFTs, and they click and like to purchase in particular the 3D NFT that you put for sale. They're going to go through the same motions of choosing between payment with crypto and payment with fiat currency, and when they select payment with fiat currency, they are going to put the number of their debit or credit card expiration date, CVC, and when they complete this transaction, there is going to be a transaction and conversion from their national fiat currency to US dollars, and the payment is going to be deposited in our bank account in US dollars. Then we are going to do a transaction and transfer of ownership from you to the second user, and now the second user becomes owner of this 3D NFT. Then we are going to make a transaction and conversion from US dollars to your national fiat currency, and deposit the payment for the sale of the 3D NFT in your bank account in your national fiat currency. With this said, I'm ending talking about this second project. The third project I like to talk about built an entertainment system where there are currently 2 artificial intelligence entities, and each one of these AI entities is outfitted with gender. They're outfitted with their own avatar image. They're outfitted with their own voice with which they're speaking. and the voice has a specific voice pitch, which could be high or low, or somewhere in between these high and low pitches. And this AI, each of these two entities is outfitted with their own large language model, and they are assigned by you, the user, the initial prompt and the context of this interaction. And the second AI entity as well is outfitted with their gender, avatar image, voice pitch, their own different large language model, and you, the user, is assigning their own initial prompt and the context of the interaction. Then you can start this interaction, and you're going to observe the first AI entity generating some response, which is going to go to the second AI entity, and the second AI entity is going to reply based on what they're fed by the first AI entity, and then submit this to the first AI entity. And then you're going to notice this interaction going back and forth between the first and the second AI entity. And at some point you could stop this interaction, and at this point you could be having a choice to save the transcript of this interaction on your local computer system. And you could also post the parameters of this interaction on our 3D NFT, on our AI to AI website. And now is the time to tell you the name and the URL of our AI to AI project, and it is AI to AI.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I followed by the number 2 followed by two other letters A and I, and it is typed all together AI to AI. Then there is dot, then there are two words, decentralized and web. Then there is dot, and it ends with org. Once again, AI to AI.decentralizedweb.org. But what could the example of this interaction could be between currently two AI entities? You, the user, could outfit, for example, the first AI entity to have a female AI gender, female image avatar, female voice pitch, which is usually a high voice pitch, and choose their own large language model, and then you could assign the initial prompt to be very seductive or very flirty, or like very kind, or like very saucy, for example. And then on the context you could put basically asking questions and responding to questions. And then for the second entity you could, for example, assign it male gender, male avatar image. You could assign it the male voice pitch, which is usually low voice pitch, and you could assign their own different large language model, and we have a big choice of large language models, and also you could assign it the initial prompt to be very angry or very resistant to suggestions, or very mindful and thorough in their answers, or anything you else that you like in particular. And for the context of this interaction, we could put the same thing as questions and responding to questions. With this set, I like to repeat once again the website and the URL of this project. It is ai2ai.decentralizedweb.org. With this set, I'm going to the third project that I like to mention, and this project is currently does not have a released website, and it is in development. And this project specifically does is token counter, and this project does specifically count the tokens that users generate when they post requests, and the tokens could be input tokens on their request or a prompt that they're sending to the AI model, and the AI model is replying, and this reply also is coming with a token count. And you could also instruct the AI model to have a cache and save your requests and its responses internally to the AI model, and this also is counted with tokens and has a specific pricing. And by having this token count, we could be having the exact number of the requests done to the AI model, and the tokens which are generated by the models, and we could be aggregating this and doing maybe some kind of chart which we could give the users, and this chart helps them with their budgets and what they're spending, and it also tells them about their efficiency, if they did actually generate some product based on the requests and the answers, and did they serve specific customers and specific people, if this is the kind of chatbot which does help desk for people coming to a website. With this set, I also like to mention another project that we're working on and we're building, and this project specifically counts and records the steps that the user, is doing when you go through specific programs on your computer systems, being it your laptop or your tablet or mobile phone, and you could be doing these steps through a browser or through a program, and this second project is recording these steps, and you, the user, could request start of the recording, and then as you go through the steps, on the final steps you instruct the this specific project and the program that we're building to ask user permission, and then you stop this recording and label this interaction in a specific with a specific thing. And what could this record of this sequence of steps could be? For example, you could go to one or more like food stores, searching for a specific food item, and then you, at the last step of this after going through this sequence of steps, you could like make the payment and request delivery of this food item to your home. Another type of recording could be purchasing a ticket for a concert which is coming at a specific dates and times and specific locations and venues. The third thing you could be recording a sequence of could be buying airline ticket and flying to one or more destinations at specific dates and times using specific airlines or specific travel websites. And in addition to this, you could also request like accommodation in specific cities at specific dates and times, and you could also request like getting a rental car or getting tickets for entrance at specific museums or venues. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.